Assess 17, page 160, question 3 says this: a rectangular enclosure has dimensions x by 2, so that's the length, and it's by 3 minus x meters. So, and it's going to have an area. The area has enclosure, and it's given by the formula area equals minus x squared plus x plus 6. Really, we've got y equals minus x squared plus x plus 6. But since y is represented by the area of this rectangle, they've substituted the letter a instead. Makes no difference. We're still going to get a little graph, and it goes minus x squared, so it may look a little bit like this. I don't know yet until I've actually done it. And that will be the maximum point. And if that's the maximum point, we can read across where the y-axis has a maximum value, and that will be, if you like, the maximum area. And that's what part C is all about: find the largest possible area of this rectangle. So we're going to get a graph. It's going to look like that. We're going to hit a maximum, turn left, read off the value for y, and that will in fact be equivalent to the area of that enclosure just there. So here's a grid ready to go. Let's substitute some values in. So I've got minus 1 squared. Well, it's 1 squared then minus, by the way. Then add 1, then add 6. That's the formula. So 1 goes there and 1 goes there. Let's do it. 1 squared is 1, but it's negative, so it's minus 1. Minus 1 plus 1 is 0, plus 6 is 6. Now I've got the point 1, 6. Next one, minus 2 squared plus 2 plus 6. 2 squared is 4, but it's minus 4. Minus 4 plus 2 is minus 2. Minus 2 plus 6 is 4. Got the point 2, 4. Minus 3 squared plus 3, add on the 6. Well, that's 9, so negative 9. Minus 9 plus the 3 is minus 6. Minus 6 plus 6 is 0. So I've got 3, 0. Next one, minus whatever 4 squared is, plus 4 plus 6. So minus 16 plus 10 is minus 6, isn't it? Okay, so minus 16 plus 10 is minus 6. So that's going to be 4 minus 6. And finally, minus whatever 5 squared is, plus 5 plus 6. Get the answer in a minute. So minus 25 plus 5 is minus 20. Add on 6, minus 14. So we've got 5 minus 14. And I've now got to try and draw it. Let me have a good look at that. I'm going from 1 to 5 in this direction. I've got to go from minus 14 to 6. Let's add another page, I think. We'll try and do that next door. Oops. Add a page. Bam. Oh, I've got it. Good. So, right, so look. 0 to 5 and minus 14 to 6. It's been quite a long line, isn't it? Let's go really big on this. Let's hope this fits. I'm going as big as I can, really. If I start to work, it's going to be, let's check again. Right, minus 6, 6 down to minus 14, so I want 20s. Okay, so 6, I won't write them all in. 4, 2, 0, now going to negative territory. Minus 2, minus 4, minus 6, minus 8, minus 10. I'm doing it the long way because I could have had this on the screen originally, but I wanted to expose you to my thinking. There's nothing lower than minus 14 on the y-axis, so I'll stop there. And I'm going from 0 to 5 in this direction, so let's stretch it out a bit. Just do it long enough, that'll do. And I can use whole units, they're all independent, so it doesn't have to be the same scale. 1, 2, 3, 4 and 5. So there's my a-axis and my x-axis. Alright, so x and a, where a is in fact equivalent to the y. Is that alright? So now I can plot the way and have fun. Right, plot 1, 6. Here we go. 1, 6 is there. Then I'm going to plot 2, 4. 2, 4 is there. Then we're going to plot 3, nothing. 3, 0 is there. Then we're going to plot 4 minus 6. 4 minus 6 is here, and then we have to do 5 minus 14. So 5 minus 14 is that one there. Now don't be worrying yourself about this. It's still a curve, but there's no negative values. The graph would go up, hit a maximum, and come back down again like so, alright? But you don't have negative lengths, do you? You have a length, but you don't have a negative length. But we knew it was going to be an upside down graph because it's a minus x squared graph. So we knew that was going to happen. I didn't know where it was going to appear on the axes until I started plotting. But that is it. That is the graph. So I'm going to start doing that. That's the relevant part to it. I'll now try and draw the thing freehand. So I'm going to start from there and do this. Oh, this is difficult. It's very difficult for me. Right, now let's have a look. Yeah, okay, and okay. Right, let's try and answer some questions. It says, construct the table. I've done that. Draw the graph. I've done that. What is the largest possible area this graph can have? Right, I'm looking for the peak here. It's going to peak there, isn't it? So if I was to put 0 in this equation here, if I was to put 0 into this equation, then I'm going to go 0 plus 0 plus 6. So I've got 0, 6. I'm going to plot that. So that's going to help me to answer the question. So 0, 6 is the genuine part of it. So this is going to peak and come back down. So I'm going to continue drawing this. I'm going to get rid of these axes, because these labels, because they're in the way. I'm going to do this now. So I've got this point to aim for, come round and come back down again like so. I won't go any further. So this is still my y-axis, and otherwise known as the a-axis. Now if I've got the points 1, 6 there and 0, 6 there, then the maximum point will be about there, won't it? So here I've got x equals 0.5. I can then substitute, what does it say? What is the largest possible area this rectangle can have? Well, I'm not going to read it off the scale because I've got above 6. It looks like about 6.4, but I'm going to calculate it. So I learnt my lesson from last time. I'm going to calculate it using that equation. So here I go. I'm going to substitute 0.5 into that x value there, then pause and check the answer. Right, here I go. Let's work in blue. The equation is, work down here, minus x squared plus x plus 6, and that's the area, or the y if you like. I can sort of read it off, but I'm not going to do that. So the area is going to be minus 0.5 squared, because that 0.5 represents the maximum point. So let's just label that in blue. That's the maximum point, and the coordinate's going to be 0.5 something, and that's exactly what I'm going to calculate now. Just tidy it up a little bit. 0.5 comma y, and that is the maximum area I'm about to work out. So 0.5 squared, but it's negative, then add on 0.5, then add on 6. So 0.5 squared is going to be 0.25, so it's minus 0.25 plus 0.5 plus 6. Well, that makes 6.5, take away 0.25, 6.25. Do we have any units in the question? Yeah, 0.25 meters squared. I'm going to pause that and I'll get back to you. Okay, Houston, we have a problem. Looking at the answers on the Assess 17 question 3, they're actually using this equation. Now I'm going to write it down here and go on record that they've got it wrong. So this is what they say: y equals, look at the table here, minus x squared plus 5x and then minus 6. That's what they're using, and of course the y is still the area. What it says in the question on page 160, question 3, it says the area, or the y, is minus x squared plus x plus 6. Okay, so that's on page 260. and this is in the answers. Well, two completely different equations will give me completely different graphs. Therefore, the maximum area for the question we have in the book is going to be 6.25. We have to ignore the answers in the answer book because it's a different equation that they're using. And what they did do is, in fact, they got a different x value, and I won't tell you what that is. They just substituted it into the equation and got their answer. And it's shocking, it really is. It's completely different questions. So somebody wrote question 3 on page 260 and somebody else did the answers, or who knows what happened. But I'm going to stop there, and I'm happy with that question as it stands. I won't change anything because that's the question that's actually in your books in front of you, and that is that.